Okay, we're solving equations that have logarithms in them. Okay, so in this case, they're giving us some nice easy ones to start with because we don't have anything with the logarithm. It's all by itself on one side. So all we have to do is rewrite it so we have an exponent. So remember, the logarithm is always equal to the exponent.
Wait, could you explain to me really quick what exactly is a logarithm?
It's another way to write the exponent. So this is saying this will give you the exponent. It's just another way of writing it. Instead of saying like 2 to the x gives you 8. Okay, because we want to figure out what x is. It's a way to find. We don't know what the exponent is. We could say this would be the same as saying log base 2 8 gives you x. And this way we can use it to solve for the exponent. It's just another way of writing it. Okay? So in this case, if we were going to write this one, so we had an exponent, how would you write it?
It would be 3/6 3/2 power equals x.
Okay, so now we got rid of the log. We've got x by itself. So now all we have to do is figure out what is 36 to the 3/2. If you're going to type it on your calculator, I think it does come out nice. I would put these in parentheses. 216. Okay, you have to put the fraction in parentheses or your calculator won't like it and they won't know what to do with it.
Can you do 1.5?
It does. That's fine.
Can you do 1.5?
Yeah, okay, let's try B. Same idea. What are we going to do on B first? How are we going to do that? And again, I put those in parentheses and in my calculator. I think this one comes out nice as well.
27.
Sorry?
27.
What is it? Gross. All right, do we need to do another one? I think you guys got it, right?
That's me a lot of those.
Wait, maybe?
There's a couple.
All right, going on. So we can use the following property to solve logarithmic equations and have logarithms with the same base on both sides. Okay? Just like when we had 2 to the x equals 2 to the negative 7. All right, so by something like this, what does x equal? 7, because the bases were the same, right? So we know that the exponents were the same. Same idea, exactly the same idea. We're saying if the logarithms have the same base, in this case 5, and this is a 2, then I can say that the exponents are going to be the same. Okay, so this would be x is going to be 8. So if I plug it in, if x equals 8, then I can write this as log base 5 of 8. Okay, sorry. We did it when it was like with this, but I don't think we wrote it with the logs. But it's the same idea, you're right. Okay, so on part A, notice that we have log base 2, log base 2. They're the same bases, therefore I can say this part is equal to this part. So x squared minus 4 equals 3x because I have log of the same bases. It is so much easier. Look at that. All right, so how are we going to solve for x? Oh, not so easy, baby.
Should we get probably
No, add 4.
at minus 3x?
I would do everything over, so I have 0 over here. Because what can we use when we have the quadratic?
That's good.
Yeah, the quadratic.
There's no way.
You could factor. Yeah, I always think the quadratic formula is easier, but you could factor, that's true. Okay, so what is the quadratic formula? Do you remember it? A would be
B plus or minus square root.
Shannon.
B.
Square.
B squared minus 4x.
Divided by 2x.
All over 2. All right, so what's our A, B, and C in this case?
3 plus or minus negative 3 squared minus 4
Alright, so we just use quarter of rule, we plug everything in. Thinking code of operations, we're going to do everything inside this corner box first. Okay, so we're going to have negative 3 squared is 9. Okay, then negative 4 times 1 is negative 4. Negative 4 times negative 4 is a plus 16. What's 9 plus 16? So this is square root of 25. So I have 3 plus or minus 5 over 2. So we have 2 answers. So let's see, 3 plus 5 gives us 8. 8 over 2 is 4. 3 minus 5 is a negative 2 over 2 is negative 1. Alright, now, the only thing I have to check is make sure that we don't have any extraneous solutions. In this case, negative 1 is extraneous. Because you cannot have a negative here. You can't take a log of a negative or a 0. It has to be.
If it was negative 3x, which would equal a positive, because people are going to be 3, is that right?
Then it would be alright. Okay.
So anything negative or 0 doesn't work.
Right, when you plug it in, you have this is either a negative or a 0, it's extraneous.
What about the other one too?
Same thing here.
Okay.
Yep. So in this case, x is just 4. You can't have negative 1. This negative 1 would be extraneous. Because you can't take a log of a negative.
Yeah.
Nope. Can't do it. That's because, remember when we had when we were graphing these things, and it looks something like this? Okay, there's always an asymptote where it hits a wall and it can't go any farther. It's always going to hit a wall at a negative, or at a 0. It can't go past it, ever. It just doesn't work. Alright, do you want to do this one, or do you guys understand? Today, I don't think so. Let's do that back. Today, no, they're going to be the same. Alright, do you want to do the next one, or do you want to move on?
If we are good as well.
Alright, wait for everybody to be with us. Yes, you can.
Is it your home? It has to be.
Okay. On the back. Alright, on the back. So the polynomial can be used to solve logarithmic inequalities. Basically, we're going to do the same exact thing, except we have an inequality, so we'll have a greater than, or less than, or equal to sign. However, if our base speed is greater than 1, that means x has to be greater than 1. If it is, or what's the answer? Okay. We're looking at this. Let's do it here. So if the log itself is greater than something, then x has to be greater than a base to the y. So in other words, we just have to be careful when it's a less than, because we have to put it at 0. I'll explain with an example make more sense, I promise. It makes more sense to me. Alright, let's look at this one. If I'm going to solve this inequality, first, since the log is already by itself, I would write it so we have an exponent. What's our base? 4. What's our exponent? So we're going to have 4 to the third. And we're going to have an equal sign because we have greater than or equal to. Greater than or equal to x. Let me do that. Maybe that's what you meant. Yep. Oh wait, no. Go backwards. Where's the x comes first? Excuse me. Sorry. Why? Why does it matter that the x comes first? Because otherwise, if we put it backwards, then our sign is flipped. I see. Yeah.
Are you ever going to give us a fun assignment of saying, find x?
Yeah.
2x plus 5 equals 8. That's when math is fun.
Do
Alright.
we have a geometry assignment?
Hey!
Hey, first of all, how was Friday? What did you guys do?
It was great.
We ate a lot of pie.
You got sick.
Oh,
That's like some pie.
did you guys read a story?
Take a while.
Alright, so let's finish this one up. Let's finish this one up. What's 4 to the third? 64. So x is going to be 6 greater than or equal to 60.
I like that.
Is that the answer?
This is our answer.
Oh, I like that.
Oh my gosh. However, look at this one. Stay with me, stay with me. Notice with this one, we have a log that's less than something. Okay? We're going to write it the same way, and we're going to say x comes first. It's going to be less than. What's our base? What's our exponent? 4. Okay? Notice we started with a less than. Okay? And we can't have any negatives, so we're going to have to put a restriction on it. We have to say that x has to be also greater than 0. Because if it's 0 or a negative, it doesn't work, we cannot do it.
Wait, why do you add 0 on that one and not the other one?
Because this one is saying that x is a less than, so x is going to go this way towards something, but it has to not.
Also, whenever it's less than, that's when you.
If it was less than equal to, would we do that?
Yes, if it's less than or equal to.
If it's greater than, do we do it?
Nope, because over here we said x is greater than something, so we're going to go this way, so we don't have to worry about 0 at all. All right, so then we just say, okay, well, what is 2 to the 4th?
60.
That's
Are there these problems except like these ones?
These are pretty much what we're doing. Yep. Okay, the following property can be used to solve logarithmic inequalities that have logarithms with the same base on each side. We're going to exclude from our solution set that would result in taking the logarithm of a number, stay with me, of a number that is less than or equal to 0, because we cannot have a negative
Less than.
less than or equal to a 0. So in other words, we're going to find restrictions. We're going to find restrictions because we can't have something that is a less than or equal to a 0. We can't take a logarithm of something like that, of a negative. Okay, so just like we were talking about up here, where we said it has to be greater than 0 because we can't have a negative in there, it's the same idea down here. If we're saying, in this case, the log of base 6 of x is greater than log base 6 of 35, then x has to be greater than what? 35. Okay, so first what I would do, since we're taking math. Chandler, I think you need to go back and fix this.
It was Lindsay that time.
No, I need to.
Okay, let's do that. It actually was Lindsay. Chandler wasn't involved in that process.
Alright, first what we're going to do is we're going to find our restrictions, okay? We're going to find what we can exclude. Yes. We're going to find what we can exclude, right? So we're going to take this, and we're going to say it has to be greater than or equal to, or not going to be equal to, it has to be greater than 0.
Why not?
Because you can't take a logarithm of 0.
You can't.
No, you can't.
Why isn't it less than 0? 0 is supposed to be.
Oh, no. I'm telling you wrong. Sorry. Sorry. Okay, we're taking x plus 3 has to be less than or equal to 0. We're finding where the wall is. So we're taking what it cannot be. It cannot.
So you set them both to x
2x plus.
plus or equal to that?
Plus 1?
Would it be easier to take what it can equal to?
No, because there's infinite many possibilities. Okay, we'll figure out where the wall is. We're saying that x cannot be these two things. Okay, so right, x has to be, cannot be this. And, okay, these are our restrictions. Totally doesn't spell it right, but you guys understand what I'm talking about. That's the C and the S. Restrictions. Okay, then we can actually solve the problem. Since we have the same base, they're both base 4, we can set these equal to each other, right? Well, this is greater than.
Why didn't we do that one? The restrictions?
No, because we don't have an equal sign, we have a greater, we have an inequality, greater than or less than. So we just have restrictions.
Oh,
What?
I see.
Okay? So then if we're solving for x here,
Oh, wait, so if they both end up with negatives, that's what you're saying?
right, we're saying these are our restrictions, this is what it cannot be. These are our restrictions, because remember our simple graph, there's always an asymptote with wall where it hits, where it cannot equal something, where it can't equal a negative. So we're saying this is as far as it is. Okay.
Like, X, no. That's like the last one, answer.
This is
It's all part of the answer
this
restriction.
is all part of our answer, not quite yet.
Oh,
Not quite there yet. Alright, so what I would do then is I would make a quick line graph. You don't have to write it, make it all pretty and everything. But we're going to say, okay, well, negative 3 is over here, 2 is here, and negative a half is somewhere over here. Okay, so we're saying that x is less than 2. That means if I start here, let's say we don't have a circle, it's going to go this way. But our restrictions say it has to stop at half, negative half. It can't go farther than negative half. Okay? The negative 3 doesn't matter because it's already past negative half. So all we're worried about is the negative 3. So we're going to say that x has to be less than 2, but x has to be greater than or equal to negative half in order for it to be true.
Is there an easier way to do this?
Should be just greater than x. It can be equal to because then we have 2. This is how it is.
I can't even picture how.
It can't even be negative half. It goes up to it, but it can't be negative half. Because then you have
Is that on your dash then? Or that 11?
yes.
Ah.
All right, let's try this next one. Okay, first, let's do our restrictions. Okay. So in this case, x, oops, this is one.
That's going to go to negative 1 now.
And x is,
That's going to equal to negative 1.
okay, those are our restrictions.
Wait, so it always has,
I'm here that
Where
we're,
it cannot be.
wait, so the negative 4 is nothing.
In this case, probably won't have to. Okay, now let's actually solve it. Since our bases are the same, we can set these together, less than or equal to.
Well, they're not the same.
Then that's not what we're going to work with in this section. They're obviously the same.
Wait, well then in the first problem it says it cannot be negative 1/2. Then the answer has to be negative.
It's because we're saying it's going to go all the way up to negative half, but it can't go beyond it. Alright, so in this case, if I solve the green part, what do we get?
X less than or equal to 3.
Next that I did would make a quick line. Here's 3,
Why do you need
here's
to
negative half, here's negative 4. If x is less than 3, it's going to go this way. What's the first restriction it's going to hit? Negative half. So x has to be greater than negative half. It can't go past it.
It can't be.
It can't be. It can't be. No, it says.
Yeah.
In this case, these are our restrictions. What it cannot.
Oh,
It cannot be.
That's what I think.
so it can go all the way up.
So it can't, it goes up to negative half. That's.
If that makes sense. You know, it's the other side. All right. Any questions on things? Here is your homework.